Okay, first try, not bad. Okay, so then I want to show you some of the effects of moving this coil up and down. We can brighten this bulb by moving the coil up, but it draws more amperage. So about, like I said, about halfway is a 100 milliamp draw. Let's check that out. Hook it up, and pretty much on the money. 96 milliamps. So that's pretty good. I'll show you by moving the coil up. Milliamp draw is higher. So there's some tuning you can do with this. So I'm just going to start it around 100 milliamp. Hey, spot on. That's pretty good. It's a 5 volt. It says 0.6 amps. So I just want to show you the difference. So I'm going to hook that up to the amp meter in the 6 volt battery. Okay, so here we go. So I'm pretty close to 0.6. So this bulb is almost 0.6 times 6. So that's 3.6 watts. This is both of them running on the same 6 volts. I didn't realize that this one is a really warm white light. This one's kind of blue. Anyway, that's both of them together running on the same battery pack. The amp draw is 0.206 to 08. Right, I finished it, painted it a little bit, kind of antiqued it, and I didn't realize this, but I had put a smaller bulb on this. I mean, you can barely tell the difference. But this is a warm white bulb, and it's like a 9 watt, and this is a brighter white 14 watt. And I didn't realize it actually snaps right into the same base, so I put that on. I just shot the coil with a little bit of black. You can still see some of the copper through it. Hit this with a little bronze metallic paint for fun. And I was going to buy a lampshade today, but I didn't. Anyway, you can imagine a lampshade on it. So I tried and tried to fire this up with 12 volts, and I sometimes could get it going. Sometimes it would burn the transistor out. And I don't want to recommend something really unreliable. The setup we did works great with 6 volts, 9 volts up to 10, but at 12 it's just a little bit iffy. It was pulling like 240 milliamps and it would burn out. So I want to show you an easy fix if you want to use 12 volts. I just tore the little transistor out, and I bolted in this power transistor. That is a 2N3055. It wires up the same way. The only difference is the collector gets bolted to, or I soldered it onto the housing there. This is our return wire from the bulb, if you can see that, and this is the emitter with the negative. So that's a pretty easy fix. It runs really, really nice on 12 volts. So if you have solar panels, you might want to consider changing out to this 3055. So I'll show it to you lit up. I don't know if you can tell. Yeah, it's pretty bright. So that's pretty nice light. So that makes a nice little light. You can adjust it by moving this down. You can draw. I have it adjusted all the way up. It's drawing 250 milliamps right up here. How I have it. If you pull that down, you can have it draw down to like 200 milliamps. I don't know if you can tell, but it's brightening when I get up here. So that's about peak right up here. So that's kind of fun. Anyway, Hope you guys enjoy this. Hope it works out well for you. I think it'll be helpful to make it more clear, you know, how to put the circuit together. If I just mount it on a board and just show the wiring kind of schematically, I think you'll see just how easy it is. I think with the lamp it might seem a little more complicated than it is. So here's the components. It's the same 9-inch coil with 30 gauge. Got a little switch. This is the transistor that Laser Saber uses with his Joule Ringer 2.0. It's a 2N3055 power transistor, and just as he's shown with my circuit, same thing. You don't need a diode. All you need is this secondary, primary transistor to invert the 12 volts to run the 120 light bulbs. Okay, so this is called a 1 1/4 inch plastic extension tube, and it just so happens it's very thin walled. Just so happens it fits just perfectly on this coil, and so we can slip this on and then run our primary and not worry about any kind of bleed through from the secondary to the primary. It gives us a little distance to run the primary, because I've found that you don't want the primary right on the secondary. It doesn't seem to work as well. So we're going to cut this. I'm going to cut it right at 9 inches. I'm going to fit it on this board. Just go ahead and slide that in. Fits nice. So our secondary's in there. Alright, so here is the circuit. It's all made, and just connect the red. You can see that I made that circuit exactly. So these little red wires are coming from the secondary high voltage coil here. That's the primary. And the big red and black are battery. And you can see that's fully bright. So next up is to try multiple bulbs, and we'll try that. Amp draw is about 200. Let's do one bulb. Amp draw is about 180 milliamps. I think that's kind of interesting. Draws a little more. That's 240. So that might be an interesting way to hang lighting. Just hang it off AV plugs. So that one is connected before the AV plug. Now it's connected after the AV. It's quite bright. So we're pulling 283. The spacing, I'm only using, I don't know if you can see that, I'm only using this much of the primary. This just doesn't work. So I've bypassed all this. So it could be if I space this out, I will actually get a little brighter bulb. So I'll probably go ahead and remove this part of the primary and just stretch this all along there. See what we can do.